Good morning, everyone. This is Lori DeToro from Fluke Accelix. Thank you for joining us for this month's Best Practice webinar. As software and sensor providers, we offer an array of webinars and other education, including product demos and product training. Our Best Practice webinar series focuses not on our technology and software, but on maintenance strategies and solutions with speakers from a variety of backgrounds to share their knowledge. We're really pleased to have with us today Alex Walter, Chief Innovation Officer with A3J Group, who will present on mobility and the future of asset management. He will also be presenting on this topic during Accelerate 18, which kicks off tomorrow. Good morning, Alex. Thanks so much for joining us today.
Good morning.
Before you get started with your presentation, I think you'll remember that you and I participated in a Facebook Live video during Maximo World, and you discussed this topic briefly. I know you'll be covering it in more detail during your presentation, but why do you encourage your clients to use mobile solutions, and why are you so passionate about it?
Well, it's really simple. Traditionally, we as maintenance organizations have always been mobile. We always go to our assets and equipment to service them. It's just now in the last 5 to 10 years that we've had the technology to be able to properly equip those technicians, and we have the technology also for the equipment to talk back to us as maintenance organizations. So those two things combined, I think, give us quite a bit more information to act upon, and I'm just excited to talk about that in more detail here today with you.
That sounds great. Again, we're really excited to have you. And before you begin your presentation, we have a few housekeeping items to go over. Today's session is being recorded, so the phone lines will be muted to minimize background noise, and we will save time at the end to answer questions, hopefully if time allows. If not, we will answer those questions on a blog post on the Accelix.com community. If you'd like to receive a copy of the presentation from today, please let us know during the survey that you will answer at the end of the webinar. The recorded webinar will be available on Accelix.com/community. And remember today that if you have questions, please ask them in the question section, and we will gather them and get them ready for Alex to answer at the end if time allows. I think that's it for our housekeeping items. Alex, let's get started.
Great. Thanks, Lori. In today's webinar, we're going to talk about the benefits that mobilizing a workforce can bring to an asset management program, as well as outline how mobility can support a condition-based maintenance program initiative. So specifically, we will discuss how a mobile EAM deployment can boost efficiency and data accuracy, how a mobile EAM deployment can support compliance and safety initiatives, challenges that organizations typically face with deployment training and adoption, and how a mobile EAM deployment can help drive a condition-based maintenance program. So my name is Alex Walter, and I'll be leading you through these topics today. I'm the Chief Innovation Officer at A3J Group. I've been working with enterprise asset management system implementations since 2001 and have been working in web deployment and technology since the mid-90s. Beyond general maintenance and EAM knowledge, I'm an IBM Maximo expert and have held certifications in all versions of Maximo since version 5. In 2018, I was named by IBM as an IBM champion for my deep knowledge of the Maximo product, advocacy of the IBM Maximo platform, and contributions to the Maximo ecosystem and community. Yes, I am a New York Jets fan. Please don't hold that against me. A little bit more about A3J Group. We're a leading implementer of asset management systems technology solutions across many industries. We focus on delivering the best user experience while capturing meaningful information through innovative technology solutions. That's our passion. We want to inject cutting-edge technology into best-of-breed EAM systems to maximize benefits to an organization's asset management program. So part of that is what we like to call our labs, A3J Labs. So when we're not servicing our customers, we're working on technology. So here's a few of the mobile solutions that we've built to work with the Maximo platform, and they are available for download on iOS and Android platforms. And of course, we've also implemented several of the major Maximo mobile products, including Fluke's Connect to Mobile and Connect to Assets solution. So let's shift gears and talk a little bit about why we are here discussing mobility with asset management. The biggest reason is that for most industries, our assets and equipment have always been stationary. Therefore, our technicians have always been mobile. It's only now within the past 10 years with the advent of Wi-Fi, smartphones, tablets, and such that we have the technology capable to support their method of work. Traditionally, technicians come into work, grab their pencils and stack of paperwork orders, and head out for the day. When they return, they either hand over the paper to someone to key in the information or wind up spending the last hour of their day keying the information into a system themselves. And the crazy thing is most organizations still operate this way. There's a better way. I read an article in January of 2018 from Terry O'Hanlon at reliabilityweb.com that said 80% of people who care about enterprise asset management cannot access their work orders on a mobile device. 80%, that completely boggled my mind. And as you can see from these figures, which were taken from a Plant Services magazine study in April 2017, the adoption of mobility for maintenance-related activities and access to their systems is severely lacking, especially as an aging workforce starts to turn over to a younger generation. There's an expectation of mobility and efficiency. So how does implementing mobility for your EAM system impact the organization? What are the benefits? So number one would be accuracy of data capture. Closing the disconnect between when work is performed and when it is recorded is one of the surest ways to improve the quality of asset data. And as we'll see when we start talking about condition-based maintenance, quality and accuracy of information is key to shifting your maintenance paradigm. Number two would be increased in productivity, i.e. wrench time. This one seems obvious to me, but recording information during the maintenance event means that you don't need either a clerk to enter all of the data after the fact or technicians themselves transcribing information from paper into the system via desktop. I've seen more than a few organizations where the technicians get in line to use desktops at the end of their shift. We don't need technicians standing in line to use computers. We need them doing what they're good at and what they're passionate about, which is servicing and maintaining assets. Number three would be support standardization and compliance. When technicians go out and do their rounds with paper, are they capturing the same information every time? Are they capturing the same information as the other technicians who are doing similar work, maybe just on different equipment? How do we know that they followed the latest prescribed maintenance instructions per our standard operating procedures? Number four, put safety procedures right in front of the technicians. So how often, kind of same sort of thing as the compliance and standardization, how often do you think the technicians carry safety procedures out with them into the field? Or do they just know that based on memory and based on training that they've had previously? And finally, and this one kind of gets overlooked, I feel like, with the focus a lot of times on cost reduction, but creating the opportunity for more value-added functions are direct results from the previous 4 bullets, especially the first 2. We'll get into more detail about that in a minute here. So diving into each one of these points, when we're talking about accuracy of data capture, when a technician records the completion of a work order right at the equipment from a mobile device, they record more complete information, including easily forgotten details like parts or consumables used against the job. Most EAM mobile applications come with the ability to start and stop a labor timer to avoid technicians having to remember how long they were at the job site performing work. And because mobile devices can be used at the point of performance, they enable organizations to capture and access information across all of their facilities in real time. This reduces errors and provides a standard form and/or workflow to capture information with. They can also capture more information, like equipment condition at the time of service or instrument readings, as well as taking and uploading pictures of problems. And when we talk about increased productivity and wrench time, again, one of the biggest benefits is allowing the technicians to do more of what they're good at and passionate about, is keeping the equipment running, right? By capturing information at the source, such as the labor time, problem cause, remedy coding, condition reports, and more, organizations are saving time by eliminating wasteful double entry and/or desktop computer access. Using device capabilities such as barcode, QR code scanning, and voice to text allows technicians to streamline the process of finding equipment and recording information. In addition, workers can leverage real-time access to parts inventory and the ability to order parts directly from the device, which saves time by reducing the need to sift through order forms at a desk later. But the bigger question might be, what can we do with all that time saving? So by having insight into the work orders coming down the line, you can make use of opportunity maintenance and reduce the cost of work dramatically. Studies have shown that reactive work is about 7 to 9 times more expensive than the same planned work order. The more you can plan your maintenance, the cheaper your work becomes. So your maintenance, repair, and operations inventory will reduce, and studies have shown that a more planned environment will directly result in a safer work environment with less incidents. Reducing the backlog will ensure that you have control on all your work, health, safety, and environmental work orders are not missed, and the work orders won't come back to haunt you in emergency work later. People often spend a substantial amount of money on reliability solutions for the purpose of maintenance planning. These solutions often have poor or no scheduling at all and end up in the backlog, effectively undermining the entire business case set out when purchasing those types of solutions. So just getting control of that backlog and really picking the head up out of the sand to take a broader look at maintenance strategy will greatly help improve operations from a maintenance perspective. When we talk about standardization and compliance, typically maintenance instructions have been located in controlled, paper-based, equipment-specific standard operating procedures or equipment manuals, which causes an inability to introduce and improve appropriate content changes in timely fashion due to laborious and complex document change control procedures. Also, an inability to easily find, use, and track adherence to instructions in the field while performing the tasks. So how often do you think a technician carries an SOP or equipment manual with them into the field. So together, those factors can actually increase compliance risk, even in situations where an organization thinks they've done a pretty good job of defining those procedures. But a more effective solution is to ensure that you have the tools to make those work instructions electronic and mobile. So having maintenance instructions located in an electronic controlled job plan that are automatically attached to the work order can provide the ability to easily introduce and approve content changes using workflow without violating those change control procedures. Also the ability to put instructions in the hands of the technicians as they execute the work via use of smartphones, tablets, or other mobile devices, and the ability to track adherence to those procedures by, if appropriate, requiring step-level responses to instructions. So these factors reduce compliance risk while at the same time improving the efficiency of executing the work. So here are some statistics related to how mobility and EAM helps promote a culture of safety and awareness. Simply having access to information such as safety plans, lockout tagout procedures, equipment manuals, work order history, and more can help raise awareness and reduce risk from a health, safety, and environmental perspective. This is another figure from the Plant Services Magazine study that shows a wide variety of EAM features that are available and commonly used on mobile devices. Everything from planning and scheduling to work execution to inventory management to personnel, health, and safety. What's interesting about this graphic is not only the wide variety of features that are commonly used, it's also the percentages. I would have expected higher percentages around work instruction, repair, inspection, and routine management, as well as planning and scheduling. But just really interesting that all of these factors are available, just used in low percentages across the industry. So just again, a few more statistics here for you. Some of the 5 most commonly used features are labor productivity, which according to the survey, looks like it's the least important. Reduce asset downtime, work order tracking and management, and then improved / real-time decision making. And interesting how they're ranked here and rated based on usage in the study. So barriers to enterprise mobility. I want to talk a little bit about some of the potential barriers to achieving enterprise mobility. We've just talked a little bit about the benefits, so wanted to talk a little bit about the barriers as well. So first thing is, don't forget the end user. This is an actual photo of a customer that was dead set against Maximo and mobility. This person had been working at the same facility and maintaining roughly the same equipment for 30 years. He was so adamantly against the upgrades and technology that he had a custom t-shirt made, "I'm too old to Maximo," and was kind enough to allow me to take a picture of him. So while the decision of mobilizing the workforce is definitely admirable and recommended, understanding end user needs ahead of time will make the transition much smoother for everyone. Having a mobility strategy that's not centered around employee needs is practically futile. An unhappy workforce will not only lead to low adoption rates and substandard performance, but also a poor return on that mobility investment. So, focusing on employees and their needs as it relates to their jobs is paramount. The second would be making sure that you choose a platform that fits the business process needs. So if the workforce doesn't have confidence in your app's ability to perform the tasks efficiently, mobility adoption will be faced with resistance. So when you're selecting enterprise applications for mobility for your workforce, make sure they're familiar, comfortable, intuitive, and make sure that the platform reflects your current work processes and streamlines every step of that process where it makes sense. The other thing is, don't forget your staff will now have a new tool in their tool belt. So make sure whatever devices they're required to carry with them out to the job site fit the form factor, both sort of compromising on knowing that these technicians will have to carry around the mobile device, but also you want to give them enough screen real estate to where they're not, hunting and pecking and really needing more screen real estate to do the jobs that they're being asked to do as well. And then we get into security and device management. Obviously, we want to make sure whatever device strategy is secure, and that deployment, patching, etc., is handled in an organized fashion. Just promotes trust amongst the technicians in the organization. Okay, so now let's talk a little bit about maintenance strategy before we get into mobility and condition-based maintenance. So as background, corrective maintenance is defined as maintenance that happens on demand due to a failure of the equipment to provide the service it was intended to provide. So usually this is due to a breakdown of the equipment or power supply to the equipment, etc. Corrective maintenance is costly because it is not planned. Any parts required to perform the maintenance activities are typically rush ordered, and labor is either being called out or after hours or taken away from more proactive work. So preventive maintenance aims to reduce failure by proactively performing maintenance on the equipment prior to failure. Makes sense. Much of preventive maintenance is based on time or calendar events, or traditionally has been, such as performing maintenance monthly or annually. Preventive maintenance certainly helps, but may lead to redundant activities and does not address rising issues that may pop up in between maintenance cycles. So with condition-based maintenance, it's all about using technology to optimize maintenance events rather than perform maintenance based on when the sun comes up. Doesn't make sense, or more sense, I should say, to perform maintenance before the equipment is about to fail. And not only before it's about to fail, but based on information that the equipment is telling you about how it's running. So a rise in technology has given birth to these new strategies. We're seeing lots of physical and digital convergence on operations, factory floors. We're seeing things like 3D printing, sensors, even robotics and machine learning coming into play that are able to, increase efficiency, reduce downtime, and enable agile operations. So we're seeing it be prevalent in delivering some near real-time service and proactively maintaining our equipment, even better than just plain old, when the calendar turns the next date. So I heard Terry O'Hanlon talk about condition-based maintenance this past year, and he asked a great question. It's kind of stuck with me now for a while. He asked, what would you say to your doctor if she prescribed a heart transplant on your 60th birthday without running any tests prior to making the decision? wouldn't you want to hold off on that heart transplant until some leading indicator of heart failure drove the need for it? And that's if it's ever needed at all. Time-based maintenance still has its place for events that are driven by factors such as compliance, and for maybe, certainly if our organization or equipment doesn't have the capability of feeding us the information, such as these leading indicators of failure. The time-based maintenance in most cases is better than your run to failure, or failure-based strategy. But on the other hand, condition-based maintenance offers the advantages of performing the appropriate maintenance at the appropriate time, given that we have access to the information that allows us to take action. Now, this will serve the purpose of only performing maintenance that is necessary when it's necessary, which keeps the asset running, reduces cost, and increases control. So the real trick to establishing an effective condition-based maintenance strategy is therefore identifying those leading indicators of failure for your equipment and pairing that with technology that can identify and quantify those indicators. So one example is run hours of equipment. Isn't it better to schedule maintenance based on actual equipment usage than just the fact that time has passed? I think everybody would answer yes to that. However, do we have access to that information? Can we integrate our EAM system with other information systems such as SCADA or other data historians? So an increase in data can lead to even more benefits, such as mining, pattern recognition, etc. We have more and more sensors and more capabilities. Our equipment is getting smarter and smarter over time, and is able to feed us information that we can utilize in order to really take advantage not only of condition-based maintenance, but once we start integrating this information into our EAM platform, we can even start to pair that and correlate that to failure in order to predict what's going to happen in the future. So really, sensors such as I've got a little photo of the 3561 vibration sensor from Fluke here. Bringing that type of information into your EAM system can be a huge benefit. And so what are the other possible leading indicators of failure that might help us with a CBM strategy? So I just talked about vibration, but you're also talking about load, acoustics, temperature, pressure. All of these can be leading indicators of failure. So it's up to us as a maintenance organization to try and identify what those are ahead of time, and then integrate our technology into play with, like I said, SCADA and other forms to enable us to pull information in to work on it. And so here's some statistics that I've found that of just sort of expected benefits of implementing a condition-based monitoring and maintenance strategy. So I want to get into a specific example, and I really like this example because this example brings both mobility and condition-based maintenance into the same use case. I talked about integrating data and getting data into your system in order to take that condition-based maintenance approach. But what if we don't have that information available to us in a data historian or in a SCADA system that we can integrate it in? It's not all, well, I don't have the data, therefore I must do some sort of time-based maintenance, we can actually use mobility to trigger inspections to go out and capture information that'll help lead to a condition-based approach. So this is a good example here. Previous customer is a large university here in the US, has a steam system with a large population of steam traps. And so just looking on basic US Department of Energy statistics, any steam system that hasn't been maintained for 3 to 5 years has about 15 to 30% of its traps in a failed state. So they're just prone to failure, and over time, approximately 20% of the steam leaving that boiler plant is lost via leaking steam traps in a space heating system. So just applying a simple maintenance program to the steam maintenance, to the steam system itself, can cut those losses in half, and implementing an even broader program can cut them in half again. So specifically for this university, they previously had time-based maintenance to replace steam traps throughout their facilities. So every 5 years or so, they would go through and do wholesale replacement of their steam traps. But they wanted to get away from that approach and implement something smarter. So what they did was they implemented a steam trap assessment program, and they were really looking to reduce energy loss, increase the safety and reliability of the steam system, decrease gas emissions, and improve overall steam quality with this program. So how'd they do it? Well, for each steam trap, what we did was we actually went out with 2 devices, an infrared detector that could detect heat, and a mobile device. And specifically, what we were looking for was is each steam trap installed and working correctly or not? And if not, has the trap been misapplied or failed in the open or closed position? So, like I said, we use the infrared device to capture the steam trap state, and then we use a mobile solution that connects to our EAM system to record the steam trap condition. Then our EAM system will automatically generate a response if necessary. So looking at this from a flowchart example here, we have a route that generates once per quarter. We have a technician that goes out and performs the route. For each steam trap on the route, the condition is recorded. Either it passes, it fails in the blowing state, or it's failed and not blowing at all. And once all of that is recorded, the route is completed and that technician's job is finished. At the same time, the EAM system evaluates each of those recorded conditions and generates a work order for each failed trap. Now, depending upon the state of the trap, there may be different prescribed maintenance, but then that maintenance can then be scheduled, and a technician will go out to perform the work and complete the work of repairing or replacing those steam traps as necessary. So rather than every 5 years or so going through and replacing the entire population, we're taking this on a quarterly basis and replacing them as necessary, based on conditions that we're taking and applying through mobility. So in summary, it's really a low effort, high reward inspection and replace program. And the customer did some ROI calculations, and came up with a $3 million per year figure that they're saving annually by implementing this steam trap assessment program. Some of the benefits, obviously, is that it's fairly easy to execute and administer, and obviously there's other benefits as far as reducing the energy loss, helping with emissions, and increasing safety and reliability of their steam system. So just a lot of benefits to doing a really simple program to get you up and running. So there's got to be downsides, right? Number one is cost. So a lot of what we're talking about here is based on data and information. So either through integrating that data into your CMMS system automatically to have maintenance events then triggered off of that data, or by implementing a mobile solution to have technicians go out and record instrument readings to then have maintenance events triggered off of those readings. Either way, we're talking about effort to get something going. We're also talking about just effort in helping identify leading indicators of failure. Sometimes, what we think as those leading indicators aren't necessarily available to us, or the information that is available to us isn't necessarily a leading indicator of failure. So getting the right information at the right time to help us know when a maintenance event is required is critical. Another thing is the age of the equipment. So newer equipment comes with newer technology that is able to communicate back to us more frequently with better information. But some of the older equipment still isn't able to do that unless it's outfitted with some control systems that sit on top of it. So yet another cost and or barrier to entry is just the age of some of our equipment. And then finally, again, we just need the systems to talk to one another. So if we have a SCADA system out there, if we have a data historian, if we have some other system that is currently siloed from the EAM system, getting those two to talk to one another really plants the seed for a lot of these innovative technological solutions and strategies. So beyond devices, what do we see? We see, artificial intelligence is not just for robots, right? We want the ability, just having information available to us, to be able to take and correlate information so that we can predict failure. The ultimate solution would be not just doing a quarterly round to capture those steam trap values, but also to be able to predict when a steam trap might fail. And having a wealth of data and having information available to us allows us to then take that step back, do some analysis on the data, and be able to predict and or learn/adapt from past incidents to know when those next and future incidents will occur. So that's next. We're pushing a lot of our customers from time-based preventive maintenance to condition-based maintenance through some of these strategies. But beyond even condition-based maintenance, we're looking at AI, machine learning algorithms, and some more predictive type maintenance. So to wrap it up here, we've got a lot of benefits that mobilizing an EAM system that can provide: productivity, compliance, and safety. being at the top of the list. But also, don't look at some of those benefits as simply cost reducing benefits. Look at those as opportunity to, maybe take a step back and be more proactive, be less reactive, and start to think about ways that we can implement strategies such as condition-based maintenance and monitoring. So that would be, number one and 1A off of the benefits of mobilizing an EAM system. And then when we get into condition-based maintenance, again, really important to know and understand how our equipment fails or has failed in the past, help to identify some leading indicators of failure, and then track that data, get that data into your EAM system so that maintenance events can get triggered off of that. And even if you don't have a just-in-time leading indicator of failure, just taking one step closer to that, like the run hours example, rather than doing something every 6 months, why don't we do something just based on equipment usage? Is a better place that we can be than a time-based for your car, like your car, for example. Are you going to do that maintenance every 3 months, or are you going to do it based on mileage or usage? And there's a place for both, to be sure, but knowing how the equipment's used can be that benefit right off the bat. But if you do know those leading indicators of failure, the closer you can get to the failure, obviously the more effective that maintenance can be. So with that, I will say thank you. I really appreciate the time, and we'll open it up here for questions.
Thanks so much, Alex. Obviously, I'm sure everyone will agree, great presentation. I'm going to be super selfish and ask my question first because I think it'll be a quick answer, but I'm just curious. And then we've got some other questions. But after working with him, did the man with the I'm too old to Maximo t-shirt change his mind, or did he stay stuck in his ways?
Really interesting little case study there. He was actually about 6 months away from retirement. So he did eventually change his mind. He did eventually adapt. But part of that may be because he, had an eye out the door. But honestly, getting his buy-in was key because what that enabled us to do was to point to him for all the other people, even though he was retiring and about to step out the door. Just seeing him buy in a little bit there towards the end, change his mind and start to get on board. I think a lot of the other people who were maybe skeptical saw that and got on board as a result.
That's awesome. Okay, thank you for letting me be selfish for a minute.
You're fine.
The next question is CBM is crucial, and there's more after the actual question, so I'll let you know when I'm done with it. Do you know of any mobile oil analysis equipment? We take samples, send them to a lab, then wait for the results. It would be more timely and efficient if we had the ability to analyze the samples on site. So do you know of any oil analysis equipment?
Not off the top of my head, but I can ask around. I actually had a customer do quite a bit of oil sampling. There's another great case study. So what they did was on a regular basis, they would send out for oil sample analysis and get the information back and record that information in their system, but they never used it to trigger any sort of maintenance events or activities for a couple of years. And then what they did was that company actually hired a predictive analytics company sent them the oil samples, and then said, we want you guys to predict or tell us when you think we had major failures on this equipment. And they were able to actually, just by looking at the oil samples and trending it over, whatever time span they were captured over, almost pinpoint when major failures occurred on that equipment. It was a really fascinating case study. But I can ask around as far as specific recommendations to solutions for that.
Great, thank you. The next question is, how do you overcome resistance to introducing CBM and an EAM in traditional, in quotes, organizations?
Well, I mean, I think just outlining the benefits is the biggest thing. I mean, here's what you can expect as far as reduced cost and maintenance, increase in the ability to plan and schedule. There's a whole host of benefits. Feel free to, I believe we're going to make this presentation available to everyone afterwards. So feel free to take this presentation and use it as a case study for what the benefits of CBM are. But my biggest recommendation would be to start small. If you could simply, like I said, if you could get from time-based to usage-based, even if it's not a leading indicator of failure, just that one simple step alone gets you closer and should realize benefits to your organization. So if you have any SCADA systems or information that's just sitting out there not being used that could be used to trigger maintenance events, figure out how you might be able to take a small slice of that information and get it over to that EAM system to start triggering maintenance events. So biggest advice is to start small, and really, if you're looking to sell this upwards, highlight the benefits. This is where the industry is going. There's lots of information out there online. Do your research, put together a good case, and you'll get it to work.
Great, thank you. The next question is, what are some technologies that you know of or that you've had success with for integrating data categories and adding a mobile solution?
Yeah, so I mean, I know we're part of a Fluke webinar here, but the Connect 2 platform from Fluke is one of the best technology solutions that I've worked with in both of these arenas. They offer mobile solutions that connect to Maximo and a host of other EAM solutions, as well as their SCADA integration and OPC connectors to feed data and information into Maximo and other EAM systems to really start the process of doing condition-based maintenance. So one of my biggest recommendations would be check out the Fluke Connect 2 suite of products.
Thank you very much. The next question is, you said the cost for CBM is a downside. Have you seen the cost of some sensor technology and integration technology decrease given the advent and the heavier usage of the IoT?
Over the past few years, I have seen the costs come down a little bit. I had that picture of that Fluke 3561 sensor. It's about the size of a chapstick at this point. So, and really a cost-effective vibration sensor. I mean, you take the little sensor, you stick it right on the equipment, and all of a sudden now the information's flowing up to the cloud and you have it. So I think the rise in technology has gotten better, both from the hardware perspective, I think, is now cheaper, smaller, easier to work with, as well as I think the rise in cloud-based solutions and software as a service has also led to some decrease in costs. You don't have to sell your IT department on going out and buying new servers and going through the whole, where are we going to put this in our IT data warehouse internally? It's much more plug and play, and I think that sort of time to value helps decrease the overall investment that you have to make.
Great. Again, reminder that there's still time to send questions if you have some. Next question is, I've been wanting to start a condition-based maintenance program, but don't know where to start. Do you have any suggestions or recommendations?
Oh, man, yeah. So I would say, we've talked a lot about this already, but start small. Start with something that's tangible, that's easy. The steam trap example is a really great example. It was very cost effective to get one of those infrared devices and equip our technicians with that. Having them go out and just take those readings on each of the steam traps really, changed the face of the steam trap maintenance program there and enabled a huge cost savings. So, with that justification, taking that back and say, okay, what's the next step? Maybe we can do this not just with an infrared gun and paper, but maybe we can outfit our technicians with some mobile technology that allows them to communicate back to the EAM system while they're at each steam trap. And so, best recommendation is to start with something tangible. Make sure that you're, able to get good quality data, and then utilize that data in a way that you can prove savings over time. And then, I think once you've proven that, it'll be easier to expand the program going forward from there.
Great, thank you. Next question is, are there any trade shows or organizations or conferences where someone might go to learn more about this integration and maybe get some education around it?
Well, I think this Accelerate conference that's happening this week in Fort Myers that Fluke puts on is a great venue for that. Other conferences, I really am a fan of the SMRP conference annually, Society of Maintenance and Reliability Professionals. They do a great job at putting on a conference really geared towards this industry. You also might consider some conferences related to specific EAM software platforms. I know IBM and the folks at reliabilityweb.com put a lot of good conferences on related to Maximo and some of these initiatives. So really a lot of good choices out there. It just depends on what type of industry your organization's in, what type of technology or EAM platform that you already possibly have. There's a lot out there to choose from and a lot of good ones. So.
Great. Thank you so much. Well, we greatly appreciate you taking the time to come and talk with us today. We just got another question in. So the question is, how does this differ from reliability-centered maintenance?
I would say reliability-centered maintenance is more of an overarching theme. If I'm going to talk about reliability-centered maintenance, what I'm going to talk about are all of the different types of maintenance, and how those all play off each other toward an overall maintenance strategy. So when I look at different maintenance strategies, I look at run to failure as a maintenance strategy. I look at time-based maintenance as a maintenance strategy, use-based maintenance, condition-based maintenance, predictive maintenance, all of these as valid Maximo strategies. So when I think about reliability-centered maintenance, I'm thinking about how I integrate all of those strategies for my equipment, for how I'm wanting to achieve peak performance of that equipment for my organization. And we can I can get into quite a bit about reliability centered maintenance, but I feel like condition-based maintenance and mobility related to condition-based maintenance is a piece of that reliability centered maintenance story for an organization.
Great, thank you. We have time for one more question. For steam traps, infrared is good. How about ultrasonic sensors? Are there mobile ultrasonic means for steam traps?
Yeah, even better, right? There, I'm not sure if if there is a cost-effective ultrasonic mobile solution available on the marketplace, but I can certainly ask around and answer that maybe on the blog or something like that and get you an answer on that. But off the top of my head, I'm not sure. This is the best I can do. I'm sorry.
Okay, no, that's great. Thank you. I started saying this earlier too soon, but we appreciate you joining us today and appreciate this great presentation. Best of luck to you during your session at Accelerate. And everyone remember this will be posted, the recording will be posted on excelix.com/community. And the presentation will be sent out to you as well. And we hope you all have a great Monday. And please thank a veteran today as you go about your day. And thanks again for joining us.
Well, thanks, Lori, and thanks, everybody. Really enjoyed it and look forward to the next one.
Great. Thanks so much. Bye, everyone.